Where's my pen? Hello everyone, it's already March 14th. Hey, it's Pi Day. It is Pi Day. Alright, maximum. This was yesterday, right? I think we said we want to do, we want to do live sweep again. I think that's what we said. Alright. Maximum candies allocated to K children. We have integer array candies. Each element denotes a pile of candies of size candies I. You can divide each pile into any number of subpiles, but you cannot merge two piles together. You are also given an integer k. You should allocate piles of candies to K children such that each child gets the same number of candies. Each child can be allocated candies from only one pile of candies, and some piles of candies may go unused. The maximum number of candies each child can get. So each is a pile of candies of this size. You can divide each pile into any number of subpiles, but you cannot merge. And I have k number of kids. You allocate the piles to the k kids such that each child gets the same number of candies. Each child can be allocated candies from only one pile of candies. And some piles of candies may go unused. Each child can only be allocated candies from only one pile, so we have to designate. Oh, so you cannot combine, right? Get the same number of candies. Each child can be allocated candies from only one pile of candies, and some piles may go unused. So this is just each one will go 5. So I can actually, because we cannot combine, right? So that means the maximum each child can get is the minimum of all the candies. That's not true. That's not true. It should be we sort this, right? If the length of candies is larger equal to the k, then we'll sort it, and the answer will be the kth biggest will be the one, right? Because we can only give from one pile, right? We can only give one from one pile, and we don't break any pile. Now the question is, if the number of original candies is smaller, right? Is smaller than k, right? If it's smaller than k, then we need to see the sum, right? If the sum is also smaller than k, then it's impossible. And then of course, if the sum is equal to k, and everybody is just be 1, right? We'll get 1 for everybody. And if it's bigger, then means we have more possibilities to get. But anyway, we'll have okay, my pen doesn't work. Okay, now it works. So what we're saying is, if we have a list of candies, and then it's sorted, so it goes like this. Then we have a k. Now, if we, that's actually not true. Because I can have, let's say, 1, 1, 1, 100. Right? And I say k equal to 3. You're not going to give me 1. You're going to try to break 100 out. Right? So everybody will get 33. Okay, I should try it. So we say 1, 1, 1, 100. 3 kids. It should be 33. Yeah, it should be 33. Ah, I see. I see. Because we cannot merge, right? So we can set a value. Doesn't matter because I know the bound. The lower bound is always going to be equal to 1. The upper bound is going to be the maximum. All right, and I can produce a mid. We just try. See if mid works. So we do mid. This basically we do divide, integer division. And to see what's the quotient. And then we add all of them together. And then, yeah, I think that's it. And then this one is just lower than 1, high will be 5. Right? And now we say on the size will be 3. And 3, it doesn't work. Right? So this will give you 0, this gives you 1. So it's too small. So I need to get a smaller. Alright, so eventually you get a 1. And it's just the 7 still now. And then you will get out. Ooh, so I think the low should be 0. Right, low should be 0. Okay, yeah. Binary search will work. It might be another solution, but let's just binary search it. Right, low is 0, high is, I don't know, we can just choose. Well, if you want to go through the whole thing, yeah, maybe you can go through the whole thing. Yeah, we'll do that. Candies. S plus equal to C, high equal to max S and C. No, S, high and C, right? All right, so once we're done, we'll check if the total sum is smaller than K. Right, if total sum is smaller than K, return 0. If total sum is equal to K, return 1. It's just kind of two edge cases. And then we say high plus plus. Oh, why don't you just start with 1? Alright, I'm going to say while low, small, high. Int mid low plus high minus low divided by 2. For S plus equal to C divided by mid. Right, and then we say if S is large What do we want to find? We want to find the maximum candy. All right, so if it's equal, we want to push. But if it's not equal, it gets too small. Right, S is smaller than K. That means it's too big. Then we say high equal to mid. Right? S is the total number of kids that can be allocated. So if S is smaller than K, so we cannot do, which means each kid get too much candy. So we need to move it down. Else, if I can, then low equal to mid plus 1. Right, then we can try to get bigger, So at the end, okay, low plus equal 1 to get out. Because we want to be this is larger equal to, right? Because we can have left over. So I think we should turn low minus 1. Two six. All right, let's try. All right, looks good. Submit. Wrong. All right, I'll figure out what goes wrong. So we have 9, 10, 1, 2, 10, 9, 9, 10, 2, 2. All right. So low is 0 and high. Oh, high and plus 1. So it doesn't really matter. We do need to plus plus. Alright, that was an oversight. I thought by this I thought we were at 1, but we're not. Dear me. Alright, this is very interesting. So in the long this thing. Might still overflow though, honestly. But we'll try. I wonder if it's worth it. I guess maybe it's worth it. 19 milliseconds. (2022) was the first time I did it. Wow, that was a long time ago. Very, very long time ago. But right now it seems just very straightforward. Now we get a max. Yep. 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 Exactly the case. Case closed. Binary search. Okay, done. This is what I like, 15 minutes, yeah, good. And we call it a day. All right, I'll see you guys hopefully tonight. Oh, yeah. Well, thanks for the comment, but I just finished and I need to go to bed. I'll see you guys tomorrow. No, not tomorrow. Hopefully tonight. Don't